What's up, Sensation? Your camera working nice.
Hey there, boy.
Hey there, boy. Oh wow, do you got a Dexter? Do you have a Dexter? But that's like an Obama type thing, yeah. Ooh, what does it say? What does it say at the bottom? Oh, omelette du fromage. Ooh, nice. Okay, yes. I like an omelet with cheese for sure. Big fan.
So it's an episode where he's obviously Dexter, if you know the cartoon. Anyway, he puts a thing on his head and he puts a record on it, like a physical vinyl on top of this thing. Like, learn French in his sleep because he's got a French lesson in the morning. The joke is that the vinyl then gets stuck. And it says, omelette du fromage. Omelette du fromage.
Oh, that's just all he keeps learning?
And then that's all he can say in the next day. But here's the joke. The French is wrong.
Ah, it's not omelette du fromage. What is it?
As a kid, you wouldn't have recognized it, but yeah, that's half of the joke because it's the only thing he can say in French is cheese omelette, but it's the incorrect French.
Oh my god.
Omelette au fromage.
Oh, au fromage. Yeah, du fromage is like of cheese. Au fromage is probably like on top of cheese.
With
cheese. What's up, Nick? Learn something every day. I'm going to a cookie run on Saturday. It's organized by one of my Belgian friends who like does like a lot of French stuff. He runs like the French speaking club in LA. But it's like, I think it's run a mile, eat a cookie, run a mile, eat a cookie, run a mile, eat a cookie. It's like a tour of like a bunch of cookie places. So
interesting.
I'll ask him about the cheese omelet because he's the authority on the LA French speaking club stuff. Let me see if I can find it. Cookie Run, Los Angeles. The Cookie Dash Run, is this it? Well, this is different. This is Cookie Run, Los Angeles Cookie Crawl. There we go. Pretty sure this is it. Yeah, this is my friend's little event. The Carb Loaders LA Cookie Crawl. 5 miles. Oh, bro, I haven't ran 5 miles in like a couple months. 4 bakeries, all the cookies.
Hold up, this is a hill that I will die on, right?
Yes. What's your hill?
Despite our linguistical differences, a cookie to me is not a hard biscuit.
Ah.
To me, a cookie is bigger and softer, like what they sell at Subway.
Sure, like like a soft cookie, but there can be hard cookies. Yeah. What Laz is like, I heard of cookies. What's a hard cookie then for you? A biscuit?
Well, no, because we make the distinction. We just say biscuit. I mean, technically they are still cookies, and you sort of have to sit there and say, well, they are Maryland cookies. But because there's a reason we make these distinctions linguistically. That
I see.
You have sort of abandoned just to make English easier.
Cookies, like you can either get like a soft cookie or a crunchy cookie or like whatever. Yeah, we don't hate. We're just like cookies are cookies. Yeah. I'm trying to think that. Wait, what's a McVitie's then? What's a McVitie's?
Digestive biscuits.
Oh, they call them biscuits? What? See, that to me is a cookie. Milk chocolate. Yeah, they do say wheat biscuits.
No.
Oh wow. Okay. Yeah, we would call this a cookie in the United States. This is definitely a cookie.
That looks like a Jaffa cake.
It kind of looks like a Jaffa cake. No, but that's a weird. I guess that's a homemade McVitie's. Hobnobs are good. Yeah.
But yeah, collectively those are called biscuits.
Collectively, he says those are called biscuits. Those are just
but
all
the thing you call biscuits are closer to scones.
Scones, correct? Yes. Yeah.
Scone.
These are biscuits.
What the English say.
It's not scones. Scones.
No, the English say scone. It's scone.
Scone. Yeah, I'm a fan of these. These are great. Yeah, but yeah, because you guys also have, it's like scones with clotted cream. You know what I'm talking about?
That's a weird thing. That's a very English thing.
Oh, maybe it's Irish. Or is it a very English thing? Whenever we go to England, my sisters love this. They love clotted cream is basically just fucking butter, right? It's just like really heavy butter. Oh, what a sensation. What's up, Amelia? Sorry, we're talking about cookies, Amelia.
And then I froze.
There you go. You're back. So wait, yeah, what's your opinion on the clotted cream?
Wait, now you're really distinct.
Oh no. Oh no.
1, 2, 3, 4.
1, 2, 3, 4.
Okay, there we go. That's better.
Okay. Papingus says, "Bro, stop making me hungry. I'm doing the hardest fast for my religion right now." Oh no. Is it Ramadan season? What season? Good to see you, Amelia. She says clotted cream is fire, dude. I agree.
Fasting's bad for you. Don't do it.
I think it's good for. I think there's studies that it's good for like up to like 48 hours, but then past that, there's not really any benefits. I'm talking like a true fast. Like you don't fucking eat anything for like 48 hours. So I need my chat to work. Where's my chat not working?
Well, no, because I mean, unless you are fat as fuck, there's no like biological benefits to like not eating all day.
I think once in a while it is good because it like apparently flushes out. It flushes your digestive system because like there's nothing in your digestive system. Like you will get rid of everything.
Sorry, that's reversed. If you don't eat, your digestive system essentially backs up.
Oh, and it's just like...
In order to clear your digestive tract, you need to eat small amounts regularly throughout the day.
Okay.
Like, you know, half of what you would eat for 3 meals, but like 6 times a day.
I've seen some benefits of fasting. I don't know, backed by science here. What are we going to like watch this like little website? It does like... It does do some stuff. I don't know. This is healthline.com or something. It seems like kind of decent. They here we go. A 2022 interview, review of research. Oh, intermittent fasting. Well, that's different. May reduce risks of type 2 diabetes. Yeah, whatever.
Again, if you're fat as fuck, that's why that works.
If you're fat as fuck, yeah. Don't be fat as fuck, I guess. I've noticed just in myself, it's a good like mental challenge to see if I can do it. And
there's better mental challenges like chess.
Yeah, chess is great too. Yes. Yeah. Healthline is no longer as good as they say. Okay, when you stop eating, it starts eating your stored fat. Yeah, to an extent.
That's correct.
Yeah, that is true.
That's what intermittent fasting does, because you're then burning it, but then only because you're burning more calories than you're taking in.
Right. Yeah, I agree with that.
Which is how you lose fat in the first place.
Or just go exercise. Go to the gym. But you need to stop eating for a while for it to do it. Yes.
If you're like ridiculously overweight, then if you intermittently fast, then that works straight away. But because there are people that are just so big that they can't go to the gym.
Can't work out, yeah, because their knees are like, they can't take the fucking weight. You can't even walk. you like immobilize yourself. It's so bad. But you know what? You would get free cheeseburgers in Las Vegas. Do you know about this? The Heart Attack Grill.
I've heard about it. Yeah.
Yeah. There's this. I saw it.
Make you sign a waiver.
Well, they make you. There's a scale in front of the restaurant, and if you weigh over, I think it's 350 pounds, you get to eat for free. This is it. Yeah.
Shit. Oh yeah, because aren't all the servers dressed as nurses and stuff?
Yeah. You were just reading about this, Amelia? Yeah, I've been here. It is kind of funny to go stand on this and like publicly shame yourself. Weigh yourself. This dude's like 95 pounds. Yeah, over 350 eats free. Over 350. Over 3
stone in pounds.
Yeah. Weigh yourself here. Yeah, and if you're over 350, they let you eat for free. It is pretty ridiculous. This guy's definitely not 61 pounds. I don't know. I'm getting up there, dude. I'm getting close to 200 now with just like lifting. Jeff's like, now I have a goal.
I'm 238 apparently.
238. Okay. All right, so you're not too far from me, and we'd need like another 110 pounds to. But then you'd have issues just getting on the plane to like get over here to go do that. It's just like uncomfortable to be 350 pounds.
Oh well, yeah. I mean, I don't think I could. I think my knees would give out first.
Yeah, exactly. I think my uncle could eat there for free. Yeah. It's ridiculous. So the food is just like, it's monstrosity. Like the menu is meant to like kill you, right? The waiters come out as like nurses. Oh, this couple is like the saddest like story. These two people, they used to not really be this big, and they would do like food challenge things as influencers, and then they did. All right, anyways, I'm off topic.
I hear the guy on the left lost most of his weight.
He did lose a lot of the weight. Yeah, the guy on the left did. Yeah. Nice. Okay, yeah, let's do some physics. Sorry. I got hungry with the burgers.
That's dope.
All right, yeah, let's start the stream. All right, welcome to the office. My name is Dr. Gold. Is a stream that helps you out, math homework, science homework, all sorts of fun stuff. Good. Y'all submitted some questions. Let's go do some questions.
The food just looks bad. No, it doesn't. Not even slightly. I've eaten across the world and that doesn't look bad. What the fuck are you on about?
Yeah.
I've literally eaten the national dishes of most countries at this point.
What's your favorite cultural dish?
My favorite. See, I'm a bit biased though. I really do like ramen. Like
ramen is
stuff,
great.
Not the packet. Not.
Big fan. Big fan of ramen.
Because they do it really nice with some decent flavors in there.
Yes, and then they do the eggs. I love the atakami. What are they called? Atakami eggs or something? You know what I'm talking about? The soft-boiled eggs. And yes, Amelia, you can just say something through chat if you want. You can also go on the Discord. If you don't want to join, if you don't want to sign up for Discord and install another app, just do this. Here, I'm gonna give you a link.
Instead of installing another app, you could just do this. Buy a fucking laptop.
You can use your phone or whatever. If you go to this website right here, well, yeah, go past it. You can upload a screenshot of what your thing is, and then that's how we end up seeing it here on the stream. Yes. Fire. Okay, Sibley, you had a question about how do I calculate potential here. Okay. This was from one of our... I want to say this is from a lecture. Was this a lecture we had? Yes, Nico Avocado. That's his name. Yeah. Nick Avocado or something. Yeah, that's who he was. Fuck. Let me remember where this was. Sorry, I gotta go look through my notes. Oh, sorry.
I know. I'm sure I saw you do this before. Or something very.
I did. I did it during one of the lectures, I think. Sid wants to come say hi. Come say hi, Sid.
You may now speak.
You may now speak.
Hello?
You can speak whenever you want. What's up, Sid?
Hey, I was just wondering, because I noticed that for those concentric shells, like the electric field, you don't have to consider the other the shells or the other regions, but for the voltage that you somehow, for example, even if it's on the outside shell, you still have to count the inner part. So that's why I'm just wondering, how are we supposed, or how are we supposed to know, or really what is the difference?
What's the difference between calculating the electric field and the potential? I got you totally. Yes. I'll pull it up. Let me find it, because I had it here. It was during this lecture we did. I just want the actual question. All right, can I just what is with this Zoom? Just please work. Excuse me. Okay. Oh, this was a whole... Okay, never mind. I know where this was. This is actually a clicker question. Okay. Yes, yeah, we'll do it. All right, we'll run through it, Amelia. Amelia has the same question as Sibley does. That's perfect. We love that. Love that. Fuck, what lecture was that? It was 17, I think. Yes. Okay, here we go.
One other thing, I was wondering, because I forget what I saw, that even if the electric field is 0, the voltage doesn't necessarily have to be 0. But then I saw an example where that because the electric field it canceled out, one was negative lambda and one was positive lambda, that they were still saying that the voltage was 0 and 2 points outside of concentric cylinders. So I was just wondering how are we why sometimes is the electric field being 0 indicative of
why is the potential 0 sometimes, right? Yeah. Okay. Let me do a quick example of what that could be. So let's say, for instance, you have a concentric sphere thing. You have a middle part, and then I want this. Yeah, here we go. All right. Can I draw my other circle, please? There we go. Okay, and then let me see if I can put a paint bucket in between this. That'd be cool. Oh, that's sick. Look, it's the Royal Air Force sensation.
I was gonna say that's the RAF.
That's the RAF. It's actually kind of cool that it automatically fills. That's really cool. Okay, let's say, for instance, that this inner thing here is at positive Q. And then let's say that this conducting shell is at minus Q. Or here, let me make this a little more like this. The RAF has a target on their plane, apparently. I mean, the Nazis kind of did too. It was just like kind of a weird crosshair.
The Iron Cross.
Okay. The Iron Cross, yes. Okay. If you wanted to measure what the electric field was outside of this like system, what would that electric field be equal to? Well, if you remember from like Gauss's law, right? So E, what is it? Integral of E dot dA is equal to Q enclosed over epsilon naught. So E, and then let's say we're going out like some distance from here, which is just like, let's say this is some distance R. And then here, let's create some, let's create some other radii so that things make sense. Yeah. Let's say this right here is B. Out to here is C. And then let's just say inside is just A. And then let me move this up. Boom, boom. Okay. If we wanted to look outside, so this is for R is greater than C. Then again, this is E times 4 pi R squared is equal to Q enclosed over epsilon naught. Now here's the interesting thing. How much charge is enclosed if we're making a Gaussian sphere outside of this thing? Well, I have positive Q from the red, from the inside sphere, and I have minus Q from, like, the surrounding shell sphere thing. So the enclosed charge here is 0. Right? So that tells me as you are greater... Yeah, exactly, Amelia. Yeah, so as you are outside of this whole thing, your E is equal to 0. Okay? Now let's look at the next part. Let's again consider, let's assume everything's conducting, okay? Like, assume everything's conducting. Okay. So, that would mean that the electric field within the blue shell, right? And so as I come in between C and B, that's also equal to 0. Just because conductors don't... The electric field is always 0 inside a conductor. Okay. Alright, so then... Here's kind of cool thing. This has like plus, 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 because this is all going to be on the edge. Because it's a conductor. And then this is going to have all the minuses on the inside here. Okay? Now, if we go in between A and B, so if we're building our Gaussian shapes here, so let's say from A to B, now the charge we enclose is positive Q. So I can say, okay, so E times 4 pi R squared is just equal to positive Q over epsilon naught. Or I would say, okay, E is equal to 1 over 4 pi epsilon naught, and then that's going to be positive Q over R squared. And that's the electric field in between. Notice how we don't ever really consider the negative charge until we're past it. And then that's why the electric field is 0 outside of C, because there's no charge enclosed. And also in between B and C, that's a conductor, so that's why the electric field is 0 as well. Okay. And then for R is less than A, E is equal to 0, because again, this is a conductor. So, yeah, 0 electric field, 0 electric field, 0 electric field. This is the only place there's electric field. Now let's say we want to calculate, this was for getting the E field. Now let's calculate the potential. So this is E field. Now let's say we're trying to get potential. How you do potential is you want to integrate the electric field, E.dl, and you want to start usually way out at infinity, because that's where potential is 0, and then come in towards where you're trying to measure the potential. So this is what we learned. We learned that like change in potential is equal to negative E.dl. Okay. And what I'm going to do is I'm going to say that V at infinity is equal to 0. You have to define, and this is what we do this. This is a very common practice. We say the potential all the way out at infinity is 0. So when I say delta V, which is like V final minus V initial, and then we integrate coming from way out to the inside, this is infinity. This is my starting position. And then where I'm measuring my potential is going to be out to R. And we're going to do this for R is greater than C. So we're going to say for R greater than C. So we're not going to measure potential yet coming in further further inwards than being at C. Okay. Okay, so delta V, right, is VF minus VI, but this right here, right, this is my initial. This is my final. So V initial here is really V infinity, which is equal to 0. This is 0. What are you doing when you have no motivation but need to learn to study? Suck it up. No motivation. I understand there. If you need to do something, this is a life skill that needs to really develop quickly. There are a lot of things in life you don't want to do, but you have to do. So sometimes setting up a little reward after you do it can help. You know, you'd be like, oh, I'm going to go get ice cream, or I'm going to go play video games for an hour. That can kind of help. Or fear. You could imagine what's going to happen if you don't do it. That usually helps too. But the best thing is just to learn how to do it, because yeah, life needs that. Okay. So for R greater than C, integrating E.dl. Here's a cool thing: E is 0 when we're greater than C, right? So here we say, okay, cool. So E.dl. But if we're looking at the potential outside the sphere, oh, did we? Oh, no, good. Outside the sphere. The electric field is 0 there. So integrating this tells me that there is 0 potential all the way up to C. So I say, okay, cool. V of R is equal to 0 for R is greater than C. Then let's look at, for instance, going in between B and C. So are we enclosing any more electric field? No. Electric field is still 0. So we'd be like, okay, cool. VR is still equal to 0 for B is in between R, in between C. Okay. Cocaine. Yeah, coffee can help. Some sort of stimulant, for sure. Okay, but then...
It's like, if you do coffee, it's like, I'm a little bit perked up. Now, if you have no motivation, you do cocaine. I'm going to clean my house with a toothbrush.
That's meth. You ever notice people that do meth have like really, really clean houses? Well,
no.
not really. Well, yeah, they try to clean.
That's still crackheads.
That's true. Okay, now let's say we want to calculate the potential in between A and B. So in this in-between zone, which we do have electric field in, right? We calculated the electric field is 1/4 pi epsilon naught Q over R squared. Like, there is electric field here. So, again, so this would be like V at, let's say, R is in between A and B, minus, again, V at infinity is equal to the integral from infinity to some R in between A and B of E dot dl. There's a minus sign here. Okay? So, going from infinity to C plus integral from going from C to infinity, these are both 0. You don't pick up any potential going through infinity to C and then going from, sorry, not C to infinity, C to B. But you do pick up some electric field and thus potential when you're going from B to R, which is in between A and B. And E there is 1 over 4 pi epsilon naught, and then it's Q over R squared. And so when I integrate this, this is going to get me negative Q over 4 pi epsilon naught integral from B to R of 1 over R squared. The integral of 1 over R squared is negative 1 over R. So now you get negative negative, so this is plus 4 pi epsilon naught. And then that's going to be 1 over R integrated from B to R. So that's going to be, I'm just going to call this K. So I'm going to say KQ, and then it's going to be 1 over R minus 1 over B. Yeah. Cool. And this should make sense, right? Because when R is equal to B, you have 0 potential, right? Right? There's no potential as you get closer to B. And then as you get closer to A, you do have some positive potential. Okay. So that's going from A to B. And then, again, the change in potential. So if we look at the potential when R is less than A, so when you're on the inside. So say when you're on here, right? Now it turns out that you're not picking up any more electric field as you go further in. So again, you could write it this way. This is equal to, so we're going to say delta V is V at some R less than A minus V at infinity, which is equal to the integral from, so it's negative infinity, infinity to C plus the integral from, and then, well, the minus sign's outside everything here. Yeah, sorry. Integral from C to B plus, wait a minute, the integral from B to A, okay? And that one does have an electric field, right? That's the 1 over 4 pi epsilon naught Q over R squared. And then it's plus the integral from A to 0, and that's also of E just equals to 0, okay? So this is 0, this is 0, this is 0, and this is the only thing that adds to the potential as you start going inside the inner charge. So think about it this way. This is like, what's up, Sibley?
Oh, sorry, I was trying to say, no matter what region you're in for voltage, you always have to keep carrying over the previous region, the integral.
Correct. Yes. Wherever you are measuring potential, because remember, potential is referenced to something. You're still referencing it out to infinity. So you have to add up all the potential that you gained as you came from 0, which is at infinity, to where you are.
Oh.
Do you see how
I get it. Okay.
So I had to add up getting to C. Well, that was 0. I had to add up getting to B. That was 0. But now I have to add up going from B to A. Where previously here, right, when I was figuring out the potential between A and B, I left this as R, because this R was something between A and B. But now, if I'm trying to find the potential inside A, so inside this sphere, I have to add up all the potential I gained going from B to A. Not just B to R.
Oh, okay. Okay, thank you.
Yeah, good. All right, yeah. That's a very important thing. I'm not sure if I actually like went over that really in class. 1 over A minus 1 over B. And then, again, you're adding 0. So this is the potential. Notice how the potential inside the sphere does not depend on R. It's just whatever the potential was outside the red sphere, and it's constant throughout the entire thing. Because you're not adding any more potential, because you're not integrating over any more electric field.
It's never dependent on the radius?
Not inside a conductor. So inside a conductor, the electric field is 0, right?
Okay.
And so when you're finding potential, you're always integrating the electric field, like .dl. Think about like you're just adding up what the electric field is to get to that point. But when you're within a conductor, okay, the electric field is 0. So whether you are here or whether you are here does not matter for potential, because coming from here to here, there's no additional electric field that you're adding. So your potential is constant here, but your potential is equal to the amount of potential it took for you to get at least to here. And then it's constant.
Okay, thank you. And why doesn't it behave like a point charge?
Good. So it behaves like a point charge outside of the radius. So look, outside here, right? This behaves as a point charge, but it's a point charge with charge 0, because this minus Q shell collapses on top of this plus Q red sphere to give you like a total point charge of 0. When you are inside the blue one, when you're in between these two, you can treat this as a point charge. That's why the electric field in between the red and the blue was the classic KQ over R squared. That was the electric field. It was just this. And that's a classic E field for a point charge. The reason why it's not like just the point charge for a potential is because you still have this minus charge here that's on like the walls. Yeah.
Okay, balancing out the charge for the overall conductor to make it 0 inside.
Correct. Yes. Yeah. In order for this whole thing to be 0, this is positive, this is negative, and then because they're conductors, the charges never hang out inside the material; they hang out on the edges. And so the positive charges on the red are going to hang out on the edge. That is going to attract all the negative charges from the blue towards the inside wall. If this thing was... good. An additional point. If this thing was neutral, then you would have electric field out here, right? Because now this would not cancel out this. So that changes measuring the potential, because now you have electric field out here. You have to add up as you come in, and then it's 0, and then you have to start adding up more, and then it's 0. And I think that's what the other question was. I think that's what this one is. Yeah. Yes, because they say that the solid thing has charge, but the outside is neutral. Okay. Yeah. And that's what this case is. So I'll pause for a second because I know people got to catch up, and I've probably just been ranting for the last 10 minutes, but
it could be worse.
It could be worse. I definitely could be worse. So I think, Sibley, do you understand? Or do you have other questions about that?
Oh yeah. Do you remember repeating what you were just saying? I got a little bit confused when you were talking about if it was neutral on the outside, then the electric field wouldn't be 0 outside of it or something. And how it relates to this, because I know that there's that insulator inside there. Mm-hmm. So I'm trying to figure out. I don't really get that part, to be honest.
For sure. Let me go through it. So this was a case where we had a conductor on the inside with positive Q, a conducting shell on the outside with negative Q. So the overall charge enclosed outside of this whole system is 0, because minus Q and plus Q cancel each other out. In this case, you have some amount of charge that is not 0 on here, okay? We end up having to calculate that using, like, an integral because the charge density isn't uniform. But regardless, this is positive. This is 0 charge. So when I'm outside here calculating electric field, I'm enclosing positive non-zero charge. I'm not enclosing 0 charge because this is not canceling out this. And if you're enclosing charge, then you will have an electric field.
Oh, got it. You're talking about the difference between the insulator, because now you're enclosing charge because it's an insulator, so there's charge inside, so then there would be an electric field. Then there would be a potential because it's the electric field direction of the displacement.
Yeah, so let me do this one. Let me do this one again, just so you guys can see it. So the first thing you need to know is you need to know how much charge is on the inner sphere. We need to know Q enclosed for the inner. Okay, I know Q enclosed for the outer is 0. And how we get Q enclosed for the inner is they tell us that it has a uniform charge density equal, well, actually, sorry, non-uniform charge density equal to beta R. So, good to see you, Haji. Okay, so if I want to find Q enclosed, right, that's equal to the integral of this. This is charge density. And then this is dV, integrating over the volume. If this was uniform, so we could say, or constant, so if rho was constant, then Q enclosed would just equal rho times 4/3 pi r cubed. This would be super easy. Because it's just density times volume. If this is not constant, now you have to integrate rho dV. Oh, what's up, Monkey Man? Monkey Man says, this reminds me, I finalized my course choice. I'm going to do electrical and computer engineering. Nice. And take Python and data structure algorithm classes on the side. Also, I started learning Python over the summer because I was bored. All great things, dude. Yes, that's a good path for you. You would probably do something with this then. Have you done this before, Monkey Man? Have you done electric field and charge stuff? Conductors, potential. This is all E&M stuff. Okay. Nice. Okay, so to integrate this SIB, right? If we want to get the charge enclosed here, what we're going to do is this is a calculus thing. We're going to build these spheres which have a surface area equal to 4 pi r squared, and then we're gonna like start stacking them out further and further, like times dr, until we get out to the total volume of the sphere. So this is going to be rho times 4 pi r squared dr. This is how you find dV using, it's called like the shells method.
And this, sorry, just to clarify, this is because it's non-uniform. If it was uniform, we would have to see the ratio of the volume enclosed versus like the volume of the Gaussian surface, right? If it was an insulator.
Yes. Yeah. So this is an insulator. This says it's plastic. The issue here is that the density is not it's not uniform. The density changes as we go through the thing. So calculating Q enclosed isn't as simple as just doing, the density times the proportion of the volume that's being there, right?
Gotcha.
It's super annoying. This question is kind of annoying. So we have to use this method, which is we're integrating surface area dr times some density. It is like rate of change of charge. It totally is. So this ends up, so rho was equal to beta r. So we're going to say beta r, and then it's 4 pi r squared dr. Okay. So if you want the charge enclosed, let's say from 0 to some r less than a. So if we wanted to figure out how much charge is enclosed here, for being at the center out to like some distance less than a. We're going to do this. So it's error r less than a. This is going to be 4 pi beta, and then integral from 0 to r is less than a of r cubed dr. And so that ends up equaling 4 pi beta, and then that's r to the 4th over 4. And then that's integrated from 0 to whatever distance in the inner sphere you're trying to measure, less than a. So if you're measuring the total charge in just the whole sphere, you're going all the way out to a. And so that becomes, the 4's cancel. You get pi beta a to the 4th, I think is Q enclosed. That's for the whole plastic sphere. That's for if you get the whole thing. Okay. So Q enclosed for the inner, that's going to be pi beta a to the 4th. So if I want to calculate the electric field outside, okay, let's say we're calculating the electric field outside. Let's say we're doing E for R is greater than C. R is outside this, okay? Then that's going to be E times 4 pi R squared is equal to Q enclosed over epsilon naught. But the only charge enclosed, if we're way out here, is from the inside plastic sphere. The conducting spherical shell is neutral. It doesn't contribute any charge. So Q enclosed is just, this is just the inner plastic, which is right here. And so you end up getting E is equal to pi beta a to the 4th over 4 pi epsilon naught r squared. Pi's cancel, and so you just get beta a to the 4th over 4 epsilon naught r squared. And that's E. That's the electric field outside. Let me make sure that was right. Oh, I need to see what the answer choices were. 1 sec. Please hold. Forgot I hid these. Monkey Man says, started watching Harvard's CS50 course. It's 25 to 26 hours. But working on the side. Nice. Yeah. Dude, there is so much self-knowledge. You can just figure stuff out yourself. It's amazing. I applaud you for doing it. It'll help you out in the future. Trust. Nice. Okay, yeah, we got it. Yeah, it's pi beta a to the 4th. And then... let me just get what the answer choices were. So then... the electric field outside, which was part B, was this one. Nice, okay. So I think we got the same thing. Yeah, there we go. So the electric field outside was beta a to the 4th over 4 pi epsilon naught r squared. So this is correct. And then if we want to look at the electric field in between B and C, this is conducting, so there is no electric field. So electric field for between B and C, that's equal to 0, okay? All right, and then here, let me make that a different color. Let me do like different colors for these things. It might help. Pink. Okay. So E for between B and C, that's equal to 0 because it's a conductor. And then between A and B, so that's here. So E, A less than R less than B, this is going to be equal to the charge enclosed, which is just pi beta a to the fourth, and then again over 4 pi epsilon naught. Oh, interesting. So the electric field equation outside the conducting sphere and inside it but outside the plastic sphere, it's the same equation. Because you're still only enclosing this charge. It's just right between B and C, it has to be equal to 0 because it's a conductor. Okay, cool. So this is still beta a to the fourth over 4 pi epsilon naught r squared. But then here's the unique thing. If I then look inside the electric field, inside the plastic sphere, so E for R is less than A, okay. Now the charge I'm enclosing is equal to this with an R. So this is pi beta r to the fourth over 4 pi epsilon naught r squared. So then this just equals, cancel, beta over 4 r squared over epsilon naught. Which I think was what our other answer was here. Yes, beta r squared over 4 epsilon naught. Nice. Okay, cool. Okay. That's the electric field in all 4 regions. I'm going to pause so that people can tell me if they need me to slow down on that. But that's an important thing to be able to do, is to be able to look at this situation and be able to calculate the electric field everywhere. And then once you have the electric field everywhere, calculating the potential is just adding it up as we go from infinity on the inside.
You're saying adding up and integrating the electric field, right?
Yes. Yes, Ib.
Okay, and then I have kind of a dumb question, or like a really
There's
basic
no dumb
question, but I know. Oh, thank you. I know how to do the process you're talking about, except I'm just a little bit confused about those boundaries.
Yes.
It says like between R is less. If it's saying R is in between like
B and C,
does that mean that Does that mean that it's like within B or just at the edge of B?
At the edge. Yeah, it's not at B. Yeah, there are like weird things that happen exactly at the boundary. So we always say like greater than and less than. I'm not going to mark you points off. Like as long as you say like it's in between B and C, cool. I think I forget if it's like technically equal to or something, but yeah, just outside of it. I'm pretty sure.
Okay, but it's like.
What did they say? Yeah,
outside of it, right at the.
Yeah, they don't say at the boundary either. So if you look here on the question, they say they don't use any of the equal signs. They never have it like at the boundary. And I think it's because it's discontinuous at the boundary.
But don't include the thing between. Just don't include that area.
Yeah. Don't include the actual boundary, and I mean, because look at this, right? So the electric field when you're right outside B, it's equal to 0, but then right when you're at B, it's equal to something that's not 0. Like this doesn't approach this. Like if you took the limit as R approaches B from like coming from this side and coming from this side, they don't approach the same value. So it's discontinuous. And that's because you have all the charge just like hanging on that outside wall.
Oh, gotcha. Okay,
Yeah.
Okay, thank you so much. I can definitely do the electric field in those different regions. Thank you.
Good. Nice. So then, yeah, if you needed to find out the potential, let's say for R is greater than C. So yeah, let me do them in the same colors here. So the potential when R is greater than C, that's equal to the negative integral from infinity to C of E dot dl. Infinity to some R less than C. You leave this as R because you want to be able to plug in R and figure out what the potential is at any location R that is outside of C. Sorry, R is greater than C. I'm getting confused here. All right, that's negative integral negative infinity to R is greater than C. And then this is beta a to the 4th over 4 epsilon naught R squared dr. So that's going to be equal to, the integral of 1 over R squared is negative 1/3 R to the, wait, no, you raise the power. So negative 2 becomes negative 1, you divide. Okay, cool. So it's beta a to the 4th over 4 epsilon naught, and then it's 1 over R, evaluated from infinity to some R is greater than C. Good. Why is the blue region the same equation as the outside? Yes. So when you're in the blue region, right, the electric field only depends on the charge you're enclosing. So in the blue region, you're enclosing this charge, this red charge here in the center, right? That's all you're enclosing. And then it's 1 over R squared for going outside of it, for being for any electric field outside. Then when you're outside the shell, okay, you're still enclosing the same amount of charge. The only difference is your R out here will be much bigger. So the electric field equations are the same, except, sorry, there's not a pi here. Sorry. Yeah, this should just be 4 epsilon naught. Pi's canceled. These are the same equation. The only difference is that here, when you're in between A and B, your R value won't be as big as if when you're outside the sphere here, then you'll have a much bigger R. So the electric field is not the same, but the equation for the electric field is. You're still changing what your R is. You're still either going really far out or you're like in between the two, the shell and the sphere, to calculate your electric field. The only like break here is the pink, which enforces that there's no electric field there. So I think we have a picture of this somewhere. I did it. Yeah, if you do a picture of the electric field, it's pretty cool. Yeah, so the electric field goes to 0 from R equals A, so it's like this. And then this is out to like, okay, let me put some dashes. This is at like A, and then it starts to drop as 1 over R squared. But then the electric field is 0 here, and then it continues to drop. So there's like just this discontinuity. So this is like E versus R. It's just the bounds that are different. Correct. Yeah. And then when you're doing potential, so you need to add up this. And then when you're finding the potential here, so this is the cool thing. So V here is equal to V here. So V in this whole region is equal to the same thing as here, because you're not adding up any more electric field as you cross from C to B, because there is no electric field there. So then here, potential increases even more. And then here, potential still increases. It just increases at a decreasing rate. So if you wanted to look at maybe what the potential looks like as a function of R, it should look like this, or here, let me see if I can draw it. This, flat, this, and then once you're here, now you're adding up area, but at a decreasing rate. So it's going to look something like this. Or, sorry, you're not adding at a decreasing rate. You're no longer adding at an increasing rate. So it actually, it goes 1 sec. Derivative of that is still positive. Oh, no. I was right. Sorry, I was right. It is doing this. Yeah. Also, right, the slope of this is equal to this. Right? So here, the slope, remember that, I think it's E is equal to negative nabla V. So the slope of potential is 0 here, and that's why the electric field is 0. The slope here is going from increasing to decreasing. So that's why it's the slope here, right, is, well, negative increasing to 0. The slope is 0. Yeah. Yeah, so actually, yeah, but right, the slope here is really negative, but then negative slope means that it's a positive number. So here, like, E is positive, and then here you have E is equal to 0. And that's shown here, right? You see here? Like, E is positive. E is positive. E is equal to 0. Yeah. Okay. I'm not going to do all these integrals because it takes a very long time, but I hope this makes some sense. This is a very, I would say, like, stereotypical question that comes up on whenever you're doing, like, electrostatics, and especially Gauss's law. This is a very, because it incorporates potential, incorporates electric field. It also incorporates, like, how to calculate charge. These are all, like, important things. So.
Thanks so much. I got it. Thank you very much. I appreciate it.
You're very welcome, Sib. Yeah. But yeah, feel free. If you have any other questions, just submit them. I'll do them. Nice.
Thanks. All right. Oh, just one more question. Sorry.
What's
you
up?
were saying yesterday about the capacity. You were talking about yesterday about the capacitance. You mean like in terms of like calculating between two, for example, like cylinders, like you were doing yesterday, or two like metal balls or something, and then figuring out voltage and putting it into the equation? Or are you talking about like look at the circuits, or just like
so both,
lightly, like for the circuits?
Yeah. So for the circuits, right, being able to take like a system of parallel and series circuits and figure out what the equivalent capacitance is. That's a good example of like one of a shorter questions to do. Calculating the capacitance between two. What's up, Don? Calculating the capacitance between like two shapes using Gauss's law. That would be like an FRQ. That's a much longer question to do. I would say know both, right? Know how to like find the capacitance of like a series and parallel circuit and a combination of the two, and then also have a little bit of experience with how to calculate the capacitance of the two concentric shells or two rods. That's another good one.
Okay, thanks a lot. Thank you. I appreciate it.
You're welcome. Yes. Nice. Good to see you, Don. What's up, Don? The Don father. Don Factorial, dude. Shout out to Don. Don's great. We were doing... Don, weren't you doing physics? Did you ever get to this? Did you ever get to doing Gauss's law with electric fields and stuff? We were just going through like a murder electric field and potential. So many integrals you have to do for this. RN Mozzarella says, I've been subscribed to you for a bit. Are you a tutor or a professor? Answer is both. I currently teach physics at UCLA, but I also tutor a lot. So I do both. Yeah, we got all the way through Maxwell's equations when I was doing E&M last year. Yeah, I remember you doing that. Yeah, that was very cool. Yeah, this is super fun. It's interesting. I think a lot of the students would say this is not super fun. I think it's fun. Yes, Nick, we'll do your math. Yeah. Nice. Yeah, so we help out with all sorts of math, science, whatever class people are taking and need help with. This was specifically for an E&M class that I'm teaching at UCLA. They have a midterm on Friday, so I was answering some questions on how to calculate potential and electric field for various configurations of conducting spheres and all sorts of stuff. Yeah. But Nick, yeah, here, let's do some of your stuff. Your stuff makes me happy because it's not so complicated. Nick is training to be a court officer, and he has to take like one of those government math tests, and we're helping him out study for it by doing some of his questions. Let's see, which was the last one we worked on, Nick? A lot of graphs going on here. We did this. We did this. Okay, here we go. Switch to Discord? Yeah, come on over. And you too, for our viewers and the Dawn Father family. If you want to learn some, this is a little bit more basic math, but it's fun refreshers to see like what they ask people to try to get jobs in the government. I want to do the ASVAB at some point. That's the military one, right? The ASVAB. I want to see how like difficult that thing is. Maybe we could do like a mock ASVAB on one of the streams sometime. All right. Questions 9 through 12 are related. The ASVAB was very easy. Oh, was it? Okay. Yeah, I'm just curious like how I would place in it. You know, it'd be fun, Don, if we did like a whole thing where all of us took the ASVAB and then we determined like what our ranking would be in the military, like E1, E2 or something. Like who gets to be lieutenant, who gets to be general. Because I think usually that's what that test determines, right? It determines whether you go into like officer school or you go into, well, I'm just going to be a meathead like fixing tanks or something. Well, tanks are probably actually pretty complicated to fix, but... Mealy says, I have to head out, but thanks for going through all the electric field and stuff. It was super helpful. You're so goated. Oh, thank you. Have a wonderful day, Amelia. Appreciate it. I love that the students keep saying I'm goated. That's the new compliment I keep getting. Even on like my student reviews that I got with my class last quarter, they just love saying goated. General Gold. It would be funny. General Goated Gold. I'll take it, dude. That's a sick emoji you got. All right, where's Nick? Nick's taking a while to get back to Discord. Okay, burglary rate in the city 2003 to 2008. Non-residents burglary nighttime. Non-residents burglary daytime. Ooh, okay. So, wait, the burglary rate is higher in the daytime? Who the fuck is robbing people during the day? Dude, what? What's up, Aleph? It's okay. Bro, do you remember, Claudio, when they created the, what was it, the military, the U.S. Army created a video game? I think it was called America's Army, AA, as like a recruiting tool for the military. Yeah, burglars gotta sleep too. Yeah, I guess so. That actually does make sense that, yeah, I guess most people are away from their homes and can get robbed during the day. My mom didn't want me playing it, yeah, because the government was like keeping tabs on like, yo, who's fragging out the most? Let's go get that person. I liked Operation Flashpoint. That was my favorite. I really liked that one. It's a I think it turned into Arma. I think Arma kind of bought it out at some point. Okay, at the beginning of what year was the percentage increase in daytime and nighttime burglaries the same? Ooh. At the beginning, was the percentage increase? Is this just the burglary rate? Okay. So percentage increase, I assume this means like the slope, right? Like where's the slope the same? At what year? Definitely not 2008, right? 2008. This is having no increase. This is having a lot of increase. 2006, maybe? Beginning of the year? This is also flat. This is up. That doesn't make any sense. 2005, also flat, also up. 2004? Maybe 2004? Oh, you think the graph is a percentage increase? I do agree, Jeff, because how can you have a 200% burglary rate in the city?
Obviously, don't go into.
How do you have a 200% burglary rate in the city?
We can't condone anything of the sort.
No, we can't. Live!
How do you have a 200% burglary rate? What? Is everyone getting robbed twice? Oh my god. Interesting correlation between the recession in 2008 and the drop of the increase in nighttime burglaries. Yeah. The robbers are bumping into each other on the way in and out of the house. Okay. So, yeah, this is a misleading graph, Nick, but I think they're asking for, like, at what year is it the same number? So, that's the beginning of 2004. Here, they're at the same. That's the same percentage increase. Also, I love how burglary rate is just always increasing. Motherfuckers didn't have jobs, just started doing it in the day. Yeah. Like, I don't gotta wake up for work. In what year did the percentage of nighttime burglaries decrease? Okay. This question is all sorts of whack, dude. Because, wait. The percentage of burglary... the burglary rate decreased? Dude, Jeff, what's going on here, dude? What? Explain to me.
Oh.
Yeah, what's up, Nick? I have a PhD in physics.
Phone died on itself. I don't know. It just turned off completely.
Oh no. Go get a charger.
It was 8.
Yeah, this question is fucking whack, dude. What? I can't even understand it.
What are you on?
What does burglary rate mean? we're trying to understand your graph question here, dude. It's just not making any sense. What's up, Sensation?
It's still being janky. Burglary rate, breaking and entering.
Yeah, but like, how can the burglary rate be 200%?
How? Over a period of several years? Well,
but what does 200% mean for a burglary rate? What's up, Ethan?
it means it's 2 times as big as it was when you started counting.
Yeah.
What?
I guess 200 from the first.
Oh, wow. Thank you guys. Yeah, sorry. Me and Jeff are overthinking this. Sensation and Nick are right. Yeah. Sorry. Yeah. The burglary rate relative to what it is in 2003. Okay. Except all
how you count crime stats. Yeah.
Right. Yeah. Okay. Okay. This is weird because it's almost like it's cumulative, is what it is. Yeah. And why does the dotted line not hit the origin? Maybe it's doing this. Maybe it's doing that. Jeff.
No, because it'll go back further than what's on the screen.
Oh, okay. So maybe it's normalized to nighttime rate. Maybe, Jeff. I don't know. We'll find out.
It'll be a snapshot. It'll be a snapshot of a much larger time frame.
Got you. Okay. At the beginning of which year was the percentage increase in daytime? Okay. I still think that's 2004. Because at 2004, you've had a 25% increase in burglary nighttime and burglary daytime. I wonder who created this test. Apparently the U.S. government.
Stop, Aaron!
So, no fucking shit. It's confusing. Have you tried to do taxes? In what year did the percentage of night... Yeah. How do taxes work in the UK, by the way? Your taxes are already, like, just taken care of, right? Is that kind of how it works?
Yeah, it's calculated automatically.
Yeah. That makes sense.
So
to me.
I go work for Tesco's or Asda or whatever, and I get paid such and such amount per hour, and then
Right.
the tax gets determined by the employer,
Yes.
and then that information goes to central government, and then they just know.
Yes.
And because the tax is paid by the employer to the government, I don't have to do anything.
So we kind of have a similar thing, except the U.S. government never tells us how much we owe. They expect you to figure it out, and then you can reduce the amount you owe through like tax deductions. Like donating to this stream would be a way you would pay less taxes in the U.S. Yeah. Do you have deduction things in the UK that you write off?
There's things called gift aid. That's the only thing I can think of.
Gift aid, okay.
But I'm not even sure how any of that works. I'm not sure how any of this stuff works. No, that stuff specifically. So if I give £1 to gift aid, or
Oxfam
if
or
I get
something.
£1 from gift aid, does that mean that I don't have to pay £1 to the government? But then why 1-to-1?
It's not 1-to-1. Usually what it is at least how it works in the US is if I donate $50 to a charity, they take $50 away from my reported income. So it's not like I'm paying the government $50 less. I'm paying tax on $50 less of my income. So it ends up being like, if your tax rate is 30%, it would be $15 approximately that I wouldn't be paying the government in exchange for paying $50 to a donation. Yeah.
Okay, this is going to sound like a stupid question, but how does that benefit you then?
Well, okay. Because if I donate a certain amount and it knocks my income into a new bracket, then it starts being worth it. So there are tax brackets. And so if you make over... Oh, here, let's just look up some of them. I'm actually just curious about this. Tax brackets, United States. I think I effectively paid like 20 or 30% tax last year. Here we go. Federal income tax rates and brackets from the IRS. There you go. Okay, so there is a big jump from 47K up to like, just slightly north of 47K. That's a 10% jump, right? Do you see how like you only get taxed at 12% if you make between 11 and 47K, but the second you make over 47K, now you get taxed like an additional 10%? So
if you're like way on that leading edge, then you just like pay $50
exactly
into something, and then
exactly. So say you were exactly at 48 grand, right? Then it makes sense for you to donate $1,000 so that you're now at 47, and then you should be taxed at a lower rate. But wait, the chat's like telling me I'm wrong. I don't know. I'm not a CPA, but there's a common misconception that not all your money gets taxed at the next highest rate. Oh, only the extra money you make gets taxed higher. Okay.
So yeah, that's true in the UK as well.
So I'm completely wrong.
That's true in the UK as well. If you're in tax bracket A, which is 22 grand or whatever, I'd really like you to like show US and UK taxes side by side. Actually, I know that anything, if you were a pound over that 22 grand, then you're only paying the additional tax bracket on the pound.
Yeah. I think at the end of the day, like you feel good because you're donating to charity, and whatever it does save you some money from taxes. I don't know. The rich people use this all the time to like shield their income from ridiculous amounts of taxation. I don't know what their tricks are, and if I did know what their tricks are, I don't think they'd be published on the internet, right? It's just that's where you hire some like shady tax accountant who knows these inside rules. Yeah, it's kind of like maxing donations. I see. This is if I had read like one thing lower, this would have made more. This is why it's incremental. I thought it was that the whole thing gets taxed, but you're right. It is incremental.
Our tax rates are fucking horrible. Look at this.
Well, yeah, but you have healthcare. We don't fucking have healthcare. Healthcare like costs me close to like $6,000 a year, maybe 7. Let's see.
$6,000 a year. Doesn't seem that bad.
And that's on the cheap side. Like, okay, so can I copy this image in? Sorry, let me see it. Okay, one sec. Okay, so let's copy that, and then let's get the U.S. tax rate. Okay, so starter tax rate for you guys is 19%, and goes all the way up to 48% if you make 6 figures, basically. Wow. Yeah, here our tax rate is, for 6 figures, is 24%, so half. Dude, fucking Jeff says, plus we get to live in America, and that's automatically worth more.
That's dope.
That's a good one, dude. I like that.
I'm sorry, what's that? Whose money's stronger?
Whose
That
money
would
is
be the pound,
stronger?
Yeah.
The pound. Yeah. Anyways, yeah. So I forget why we got in this subject of donations and taxes, but burglaries and other things.
So yeah, that's the joke. When someone steals something from you up north, you call it taxed.
Yeah, taxed. The kids call it phantom tax if you take someone's food at lunch. It's called the phantom tax.
Phantom.
Yeah, phantom. It's some like streamer who we started talking about the government. Yeah, so this guy, I don't know. This is the phantom tax. But apparently anytime this guy has food, this other dude comes in like the fucking Kool-Aid guy and just takes his food. And that's what the kids call it phantom tax when you yank somebody's fries.
So what's the difference between the Kool-Aid man and this guy? The Kool-Aid man says, "Oh yeah," and this guy says, "Oh yeah."
Taco Cat says we love Phantom. I think Phantom is also like one of their idols or something. It's like IShowSpeed. I don't understand the IShowSpeed guy. He just like keeps pissing people off in different countries. I don't get it. But he's popular apparently.
Yes, but people are stupid, so it's irrelevant what's popular.
Yeah, I know. Okay. Okay. So Nick, let's do this. So burglaries decreased in 2005. Good to see you, Taco Cat, by the way. Yes. Yeah. FemVox likes your shirt. Sensation.
Taco, go back into your hole.
No, Nick, be nice to Taco, dude. Chill. In what year was there the most rapid increase in the percentage of daytime non-residence burglaries? So that's these. So where did we have the biggest increase? The most rapid increase?
2008.
I agree. I think 2008's, yeah, that's a pretty rapid increase. Yeah, I think it's 2008. Yeah. Housing crash, lol. Yeah. At the end of 2007, the actual number of nighttime burglaries committed was... Oh, interesting. I don't think you can tell. Because these are all just percentages. They're just increases. Yeah. Yeah, okay. So, yeah. A, B, D, D. Yeah, that's what the answer is. Nice.
There's another one.
Okay, I'll find it. And then, Ethan, I'll do your question. Ethan says he's watching a baseball game. What baseball game are you watching, Ethan? Ethan, are you at the baseball game? Is he at like a Rockies game in Denver right now? Or is he? Are you watching it on the TV? Let me find the additional ones. Where are the other ones? Or are you just talking about like another set of questions? Like 17 and 18, Nick?
Wait, I might be blind.
Yeah, that said questions 9 through 12, and we did 9 through 12, right? 9 through 12. We did 9 through 12. Nice. Okay, cool. Good. Yay, good job. You're welcome.
Well done! Well done!
So now that it's the summer holidays.
Now that it is the summer holidays.
Started a bit early. The children are running rampant. It's
yeah, the
I didn't realise
Yabos.
how bad it was around.
Is it the Yabos? I can't tell. This is something like my mother says, but I can't tell if it's like racist now because like she used to say it when I was like a kid, which was like 30 years ago. The Yabos.
Yahoos.
No,
There's
my mom
Yahoos,
calls it.
and then
My
there's
mom says the
Yobos.
Yeah, the Yobos. Yeah, what are the Yabos?
Yobos. I think that's an Australian term.
Yabos. A yob. A rude, noisy, and aggressive young person.
That's a. Yeah, Yobo is either Australian
Yes,
or very
yes,
old
yes,
southern.
Taco. The Yabos do yoga. Oh, they are Australian then. Okay. So they're kind of like
You have to remember,
hippies.
most of the people that were sent to Australia were from London.
And they were criminals.
Yeah, because Australia was a penal colony.
Right. You always wonder. Anytime I run into Australians, they're absolutely insane. Like I can rarely find someone who can drink more than me, but it's always the Australians. They're just nuts. And then I remember that they're all like debtors and prisoners basically. I need to actually go to Australia. I've only met Australians in other countries. Okay, this is a good question. This is a physics question. Ethan. Let's see if Ethan's in the chat. Ethan, where are you at, dude? And then, yes, Taco. That's correct. You have to ask just one question a week. Australia's beautiful. It's apparently, like, very diverse, Femvox, right? Like, there's a lot of Australia to... There's the Gold Coast, there's the West Coast, whatever, the East Coast, the South Coast, Sydney.
Well, that's the joke, isn't it? It's an island and a continent.
It's an island and a continent, yeah.
And
well,
95% desert.
And a desert, yeah. Okay, let's see.
Like, all the internal landmass is a desert.
Yeah, the center of it is, yeah. It's that's where the Aborigines live or something, right? The Aborigine people. They also have like some of the craziest animals. Like there's a lot of like really deadly things. Yeah, you can chat there, Ethan, that's fine. The smallest continent or the largest island?
Nothing small about it.
Yeah.
Isn't Australia larger than the continental United States?
I don't think so. No. Is it?
Seems to be, the way they describe it.
Australia is 3 million square miles.
Okay, no then.
The US is 10.
Yeah.
Or sorry. Well, 10 million square kilometers. Here's the graph. It's close. I mean that's quite big. What's this island down here? What's this?
Tasmania?
Oh, that's part of Australia?
Tasmania, yeah.
That's cool.
And New Zealand's nowhere near. New Zealand is the distance between here and Morocco, where I am in Morocco.
Oh, wow. That's quite far. Oh, without Alaska, about the same size. Oh, okay, cool. Yeah, Alaska is huge, but there's not really much of it in Alaska. Block Y with mass My falls onto and sticks onto block X, which is attached to a vertical spring. Short time later, the blocks are momentarily at rest. At that moment, Y exerts a force F down on block X, and block X exerts a magnitude of force F up on block Y. Which of the following relates F up, F down, and MYG at the instance? Yeah, Russia is huge, but Russia is very unusable. Oh, these are always fun. So, yeah, you gotta break up, like, force diagrams separately. That's what you have to do on these. So, let's say we have, like, this is the red one, this is the blue one, or whatever. Here, whatever, I want to get a copy of this. Okay. So then if you were to look at the force diagrams on this, you have the force of gravity from the red block. So that's going to be mgx. And then you have the force on the blue block. That's going to be mgy. Or I should say myg. Sorry, one second. mxg. Which I feel like is like a sports drink or something. mxg. And then this is myg. Okay, and then because this is on a spring, you have an additional force of the spring acting only on the X block, not on the Y block. They are connected, but we'll show how that works. So now you have force of the spring on X. And then I gotta think how this works. And then the blue block feels a normal force. So we would say like force normal from the X block. Or FNY. Oh, I think I remember how this works. And that's the same force that this feels. So this is FN. We're going to say FNY, which is force of X on Y. And then this is going to be force of Y on X. Okay, I think I got all the forces. Yes, well, let me try to figure it out first. Okay. Block Y exerts a force on block X. So I think that's this. And block X exerts a magnitude of force F up on block Y. That's this. Wait, no, that's that's this. But then I think I need the whole thing to have a force of a spring on it. Right? Kind of the force of the spring is the whole thing. No, it's okay. I think it's a cool question. Let me do the simple case. Let me just do a simple so I can like get my head straight. This one does mess me up, and I literally taught this last quarter. It's terrible. Let's call this A. Let's call this B. And let's say everything's like at rest, okay? This is going to have FG, which is equal to MBG, pulling down. And then you're going to have the normal force acting on it. So FNB. A is going to have FG, which is equal to MAB, and then it is also going to feel a normal force, which is equal to the force of B on A. So, if there was no block A, right? And in order for this thing to be at rest, that means that this force and this force would equal each other. However, because there is normal force being provided to the A block from B, that means there's an opposing force from A onto B. Right, so sorry. Normal force being provided from B onto A means that there's an opposing equal and opposite force of A onto B. So that's this. And this is F of A on B. And this is equal to this. Okay. And that's why the normal force is twice as much. Yes. Okay, I think I get all this now. Okay. So here, I think force of the spring is kind of like the normal force. Yeah. This is like the normal force on this block. And yes, but then it also feels the blue force. Cool. Okay, so I think I got it. So block Y exerts a force on X, and X exerts a force on Y. I think these are the same. I think F up equals F down. Because I think this is a force pair. This is equal and opposite forces. And then MYG. Right, and then MYG... Depends if this thing is accelerating. Momentarily at rest. However, yeah, there is a net force on it because there's a spring. So the acceleration should be up. So I think it's greater than MYG. Yeah, has to be this. Because you need this minus this to be positive. In order... because there's also FKX. Yeah, okay. Okay. Is the answer choice A? Did I get this wrong? Do I have to, like, turn in my diploma? Be like, I don't know physics. Let's go ask ChatGPT real quick.
You done messed up there, Ron.
You done messed up, AA Ron!
You done messed up, AA Ron.
AA Ron. Who's AA Ron?
A third law pair, yeah. Here, let's just see if we get this. AA Ron. By lake. I need that one. Answer choice is correct. Yes, at the moment they're at instant they're instantaneously momentarily rest. Their acceleration is upwards, right? Yes. I agree with this. Cool. Yeah, okay, cool. B Locke for Blake. Answer choice is A, cool. Yes. Right, for block Y, F up minus MG must be equal to MYAY, but because it's on a spring, it's accelerating upwards, A is positive. So F up has to be greater than MYG, but then F up equals F down because it's a force pair. Okay, cool. That's cool. Nice. Love it. Good job, Ethan.
I know what you should add to the soundboard.
What do you want me to add?
Whenever someone's English is that bad, that scene where it's like, sure, we'll turn on the radio. Would you like am or fm?
Dude, I need to add in that video you have of the wedding. Was it Wedding Crashers?
Oh, what did I send you?
Yeah, with Will Ferrell. He's like, dude, that was awesome.
Movie.
Yeah.
Oh.
Is it a superhero film? No, it's Will Ferrell. He gets hit by a dart. Right?
I've lost the source now. It's not winning.
Old school. It's old school. Old school. Yeah, this scene. Yeah. That's such a good movie, Old School. ChatGPT gonna put me out of business.
No, it won't.
I don't think it'll put you out of business, Femvox. You're welcome, Ethan. Yeah. I don't think it'll put you out of business, but it is definitely flipping the script on, I think, just being like a regular tutor. I think now to become like a tutor, you have to offer something more than what ChatGPT has. So you can't just be good at like giving the answer or even like explaining it, because ChatGPT is really good at explaining it. You have to also be like a human. You have to be someone that's like personable, that like someone's hiring you because like they want like a friend, which is kind of honestly how I was getting a lot of my business anyways. Being an all-around whatever science tutor, is that kids would like actually listen to me compared to like most like problematic children who need help and are, I would say, resistant to help, don't really work well with ChatGPT because they won't even use it. They won't even ask it the questions to try to understand things.
LLMs are good for churning out information that exists. It's
Correct.
really bad at creativity, though.
I agree. It can be good to kind of set up a framework for creativity, though, like setting up like a skeleton.
Well, no,
I use that.
it's one of those things. It's one of those things where it's like you ask it to write you a piece of code, and the thing that you've asked it will already be in a book, so it can just take it from a book.
Right.
But there is no creative principle. But the only thing it does better than a human programmer at a basic level is it could just churn it out faster. But then a human can still do it better.
Can find like a more unique way for it, for sure. Jeff says if you accept that there are no new ideas, you know, right? So there's like no new movie plots, like everything's already been told. Then yeah, maybe. I think with the coding thing, there's this thing called vibe coding. Have you heard of this? Like vibe coding?
I've heard of it.
I'm going to go find it. Yeah, vibe coding is the new approach to software development that heavily relies on AI to do like all the heavy lifting, but you, the programmer, are basically like telling it pseudocode. You're giving it the logic, like the human logic on what to do, and then the AI is vibing out and like doing all the dirty work to actually write the syntax that gets you what you want.
Yeah, which is pretty much what I said before. It can do basic shit.
It can do pretty advanced shit. It can do some pretty advanced coding these days, dude. It's pretty cool.
No, because I asked it to do something slightly more difficult than simple.
Yeah.
And it just shut itself.
Oh, it did. Taco Cat says, no, I don't like the pseudocode. He's like, no, mate, you're wrong. No.
And you have to write pseudocode or you'll get nowhere, ever.
Agree. Yeah. Pseudocode is great because it's kind of similar to when you're writing an essay and your teacher tells you write an outline, right? Be like, oh, here's my intro paragraph. Here's argument 1. Here will be argument 2. Here's argument 3. Here's a conclusion. If you don't write that out and like at least jot down some bullet points, it's very hard for you to, write a coherent argument.
It is a plan. Without that plan,
yeah,
you'll just go off the place, and it's like, wait a minute, why do these functions collide with each other? That's because you didn't write pseudocode.
Right, and if you fail to plan, you plan to fail.
You done messed up, AA Ron!
I got puns for days. But Jeff is also right. He says it's good at getting the syntax right, especially when you code in multiple languages. I'll agree with that because I'm a very decent coder in probably Python and Java, but anytime I got to start doing stuff in like, I don't know, C# or I don't know, like JavaScript or any of these other like PHP whatever languages, it's so nice to just have ChatGPT just write it and then I can understand it. I understand the syntax because I'm like, okay, I see. They just have a different way of like writing functions like this and stuff.
Wait, but are you comparing procedural to object-oriented?
No. Well, yes. Yeah, well, that is true.
Python is more the latter, I would have said.
Right. Versus like scripting languages are pretty like procedural. Yes, and Jeff is like, yeah, ATAN, ATAN2, Arctan, Math.ATAN. Yeah, there's always like slight differences in what you need to write in order to do like common things. And so it is very nice for AI to just like fill in the blanks of, I'm not going to make you look up how to do Arctan in this language. It just does it. And you're like, okay, that makes sense. Vibe coding. I mean, this is even something that who's the guy from Valve? Gary something? Gary Newell? What's his name? Gabe Newell. Yeah. So he apparently like never does interviews. This guy Gabe Newell. He's the creator of like Steam. And he did this like one obscure set of interviews in the last couple days with this really small YouTube channel where he talked about like his routine and everything, but he also talked about coding, where he says AI will this funny situation he talks about where people who can't program become more effective developers of value than those who have been at it for a decade. So he's basically saying that people learning how to leverage AI right now are going to be more useful to the future than people who have been coding for like decades. I'm like, wow, it's a pretty strong statement, but it is also, it's, you know, he's the CEO of Valve. He's a beast of a programmer himself.
But he also sees it from a commercial perspective.
100%. And that's what they say in these comments here. Someone says, depends on how you define value. Value to the pump and dump hellscape of economy? Oh, yeah. Value to anyone's lives? But no. So... yeah,
it all boils down to this. If you can program without the requirement for those crutches,
yeah,
then your brain will work faster, and then the AI becomes obsolete. Because even though it might take you physically longer to type something out,
right, it
will take the AI longer to produce what you require because of how complex something is potentially. And then it will still make, and even if you get the prompt exactly right, which it would still have logical errors and stuff like that. That happens all the time.
I think the coding is great for, again, it's setting up a structure. If I tell it like, hey, I need a way to, I don't know, connect some SSH to this, and I need to do this, and I need to do this, just get me some like skeleton functions that work, and then I'll populate the math and like what I needed to do.
Well, that's the joke though, because you should have done that already in some previous thing that you've done on the previous thing that you've done.
Yeah, correct.
Code already lying around, so.
I should, but I'm not a professional programmer. So this is where they say like vibe coding. It's because you have non-technical people being able to produce things that are technical. So you have like, do you remember back in the day when it was those TV ads that would say like, hey, do you have a great idea? Sell your idea to our patent company and we'll make sure you get paid. Because like people can come up with these amazing, awesome ideas, but are probably absolute shit at the execution. Like they don't know how to turn their idea into a product. So this company would market themselves as like, hey, if you have a great idea, sell it to us, we'll turn it into a product, and we'll kick you back a % or 2. And it's, you know, a % or 2 of $1 million is better than a % or 2 of like, or it's better than 50% of nothing, because they were going to get no money anyways. So I feel like what AI does is it enables creative types, like people who are artists primarily, who don't have technical backgrounds. If they have like some cool idea for like a website or an app or something they want to do, the AI enables them to get into that field and get like a minimum viable product to like show what they have. So I think it's really cool. Yeah. It's in the same way, this works the other way, because artists are also getting mad. It also enables people who don't know how to draw, people who don't know how to use Photoshop, people who don't know how to do, you know, graphic design. They can now enter the space of artists because the AI can do a good enough job. Like the AI can do a halfway decent job of like taking my idea for like a picture or a logo and creating something that like looks somewhat decent enough to pass. So you actually get like AI is like merging the two fields together, I think, in a way. So I think it's really cool.
I don't know, I find AI's art obvious and vulgar.
Yes. Yeah, it is. You know, you can spot it from a mile away. But it is enabling like technical people to come up with like really cool artistic creative things that I don't think they would have been able to do otherwise. Well,
yeah, I mean, you've heard of Canva, presumably.
Yes, Canva, for sure. Yeah, it's a $10 billion company. She almost got bought out by Adobe for like $1 billion and said no. A 28-year-old chick. The Canva story is crazy.
I don't know why. Why the fuck did they want to buy it, right? I mean,
well, because Adobe saw it as like they tried to do Adobe Spark and Adobe Express. They wanted a dumbed down, easy way to produce content and like graphics, and that's what Canva does, right?
Yeah, and this is what I was pointing out. A company was using it, and I said,
yeah,
that's obviously Canva, and they said, yeah, why? What's the problem? And they sent me their thing that they made a whole thing, and I was like, right, this is what it should actually look like when you pump it through Illustrator. And they went,
sure,
oh, shit, that's 1,000 times better.
Yeah, but the question is like, is it good enough, right? Is it good enough for your consumers? Because most consumers are dumb, right? They can't.
Is it good enough? No, because it looks obvious and vulgar.
Do you ever see this? Did you ever see the completely AI produced like C-3PO rap thing they came up with? Gold Gang, have you seen this?
Oh, I think I saw this one. Yeah.
It's pretty dope. But again, this is a bunch of tech nerds, right? That probably have no like formal training in how to do like digital art like this. They don't know how to like create a Blender file. They don't know how to render this. They don't know how to whatever. But they do know how to use AI tools in order to get their final end result. And it's beautiful. It's brilliant. I think it's cool.
It looks cool, but again,
yeah,
vulgar, flat, obvious. You can tell that it's derived from you can tell it's derived from a derivative. Someone's typed in, "I want you to produce me this image," and then they've put it into something else and said, "I want you to make this image move."
Yes.
As opposed to if somebody did that by hand, or well, not necessarily by hand, but it would look real.
Sure. I feel like this looks like decently real to me, though. You know? And they talk about how, you know, they had to get the thing to generate like 600 images and they picked like the top 2. Like, it's a lot of time. Because you're basically like using a shotgun to like try to like shoot images and just try to get something that looks good. But, is it with like Keanu Reeves in there, dude? To me, it's still art. I know I'll get yelled at, but I think it's still art.
Again, similar problem that I had recently. I was just given a load of photographs, and that's all I had to play with. And so I had to do all sorts of stuff with After Effects and Premiere Pro, and eventually I ended up with something reasonably viable. But it still looked like a load of photographs. As opposed to if someone had actually taken the time to go around with a video camera.
And actually film it. Yeah, no, exactly. Yeah. That would just take like infinite amount of money in like CG for for an amateur, right, to produce that Star Wars thing.
Yeah.
Not to mention it'd be against all the fucking IP rights.
It probably still is.
It probably still is, but they're not making money off of it. Well, actually, maybe they are making. I mean, there are YouTube views. Okay, I gotta go teach another student. This is cool, but we'll have another stream tomorrow. So yeah, let's close it up. All right, thank you everyone for coming to Actual Education Office Hours today. Appreciate everyone's questions and everything. I had a fun time discussing all the AI stuff. Maybe we should bring back the podcast on Fridays. Fuck it, me and you could just talk. I was getting just kind of like tired of trying to find people to talk to. It takes forever. But maybe I will just start up. It'll just be the Sensation Show. You know, we just talk about things. That's how it kind of originally started.
Set up a fireworks, see if you can get some different specialities in. In fact,
yeah,
I think you should have your AI argument with an American that does programming.
Oh, okay, that's a good idea. Yeah,
because then you'll be more culturally in sync, and then you know my arguments are going to be very different from yours because whilst we're not anti-capitalist, we are further back than you are.
Sure, further in the back. Yeah. Okay. Yes. It's all back. Let me think. Yes. Okay. Our next stream is tomorrow. That will be Wednesday, 5 p.m. Pacific, 6 p.m. Mountain, 7 p.m. Central, 8 p.m. Eastern. Come on by, get some help. Do some math with us. Liberal socialists. Yep, that's us. Democratic socialists. if you aren't following all our other fun math friends, there's their. I need to update this list. But yes, have a great YouTube, Fembox. We're gonna go raid somebody. I like physics and depression. He's gonna mute me or something. I don't know why he does it, but like whatever. He's a funny guy. Very peculiar. But it looks like we're learning about current capacitors and EMF. This is very cool. So actually, if you're watching from my UCLA class, you should go watch this. This guy's talking about capacitors, which is literally on the test on Friday. Okay. Cool. Peace out, guys. We'll see you tomorrow.